Hello and welcome to everyone. In today's video, I am going to explain how to connect the registers R1 and R2 to the arithmetic and logic unit. And then I am going to explain how to connect all of these components through the bus. In the previous two videos, we discussed the registers and the arithmetic and logic units separately. Meaning we have a video explaining how to connect one register and then we have another video explaining the connections of the arithmetic and logic unit. But for the ALU, we used switches instead of registers, if you remember from the previous video. That's why it's important to keep track with me and watch all the videos in order. Today I'm going to explain how to connect the registers to the ALU and how to do this through the bus here. This is the final circuit that we are going to connect today, and I just want to show you the connections and how it works, and then we are going to build this circuit from scratch. So now we have the circuit. We have two registers, R1 and R2, and if you remember the numbers for the register, the IC number, it is 74LS95B, and for the ALU, it is 74LS83. So this is R1 and R2, and this is the ALU. What we need to do is to connect R1 to the bus, R2 to the bus. So this is our bus here. It is 4 lines, 1, 2, 3, 4. This is bit 0, bit 1, bit 2, bit 3. Because we know that for binary systems or for any numbering systems, we start from right to left depending on the weight. So for example, for binary system, this has a weight of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So this is very important, because if you don't understand this, you are going to reverse the connections, and this will make the circuit work, like providing a wrong output. Anyway, so what we need to understand here, that this is R1, R2, and this is the ALU. But where the input to this circuit should come from? If you look at this image again, so R1 is connected to the bus, and this bus is connected to the memory. So the value that we need to store in R1 should come from the memory here. Let's say this value, okay? This is R1. And R2 should get its value from, let's say, this address here, 0x101. And the output, the summation of these two registers should be outputted to this value here, okay, or this address here. But we didn't explain the RAM yet, so we are going to replace the RAM with some switches, with 4 switches. That's why I have these 4 switches here. So this is going to input R1 and R2 to the ALU. So we can consider that the switches are this area, okay? And you might say, why we don't have 2 parts for the switches, why we have only 1? This is because this is how the CPU works. We don't need two inputs here for R1 and R2. We don't need 2 buses. We need only 1 bus that has 4 bits, right? But we take the first value to R2 by enabling R2, and we have another value, then we can enable R1 to take the value from the bus. So it depends on which one is enabled here. So let's say, for example, we finished the addition operation and we want to put the output here on the bus. So we enable the ALU connection in order to put the value on the bus. So the bus is connected to all components here, but which one will read? The enabled one. That's why we have an enable button or pin for each one of these components. And that is why we need the control unit. The control unit is going to tell R1, go and read from the bus. This is the decoder here. The decoder will tell R2 go and read from the bus. It is going to tell the ALU put your value on the bus. That is really, really important. Anyway, so these switches, the 4 switches here represent the bus. Okay, so instead of reading the values from the memory, we are reading the values here from 4 switches. I hope that you understand this. Anyway, so this is our input. This is our that represents the data that comes from the memory, and this is our bus. And what we did here, do you see the 4 connections? These 4 connections are this line, and then these green connections are these connections here. These are 4 lines, not 1 line. By the way, we can connect this to this point here. Why? Because this point is already connected to the bus, so we can connect this to here. You might ask, how can we connect R1 to R2? As I said before, if they are connected together but R2 will not read from R1 or R1 will not read from R2, even if they are connected to the same point, because it depends on which one is enabled. So let's run this circuit. The input, the data that comes from the memory, that we have from the memory now, it is 0. We have all the switches turned off. So what we need to do is to turn this on. Oh, we don't see any output here. Why? We only can see this LED is on because this LED is just to see that this switch is on, nothing else, okay? So why nothing is working here? Because we didn't enable any one of them. So in order to take this value and put it to R1 or R2, you need to enable one of them. So I have here switch to enable any of them. So I'm going to take this value to R1. So I'm going to enable this. Okay, so do you see this now? So the value moved from here to this R1 register. Let's put another value to R2. So I'm going to enable this. So it worked here, but we can't see any output for the R2, any value on R2. So I'm going to enable R2. Do you see now? So we have R2. I need you to add these 2 values. This value in binary 1, 1, it is equal to 3 in decimal. And this one is equal to 1 in decimal. So 3 plus 1 is equal to 4, and this is the output. It is 4 here. So this is very important. And you can see that, let me go back again. Let me say this is also on. So the value, do you see the switches here are connected to the bus? So let's say that we need to take this value from the bus to R1. So do you see R1 is connected to the bus through these lines here? So once we enable, as you see, the value moved from the bus, this path here, to this path here. That is how it works. I think now we understand how the circuit works. I know that I spend too much time on this, but this is very important. I need to show you everything that helps you to build your CPU. I'm not just building the circuit and say this is the circuit and let's see how to run the circuit. This is not going to teach you anything. So let's now turn this circuit off and start the wiring from scratch. For the registers, we have some connections. Let's start from here. This is our image for the 4-bit shift register. Let's take pin number 7. This should be connected to the ground. So this pin number 7 here is connected to the ground for R2, and also for the same for R1. We connected pin number 7 to the ground. Pin number 14 to the VCC. So pin number 14 through this line to the VCC, and the same applies to pin number 14 here. And then we have some other pins. For example, pin number 1. This is called DS, and this is used for the serial data input. So if you are going to use the serial mode, which means the input will be a serial input, then you need to connect your serial input to this pin. But we are using a parallel input, parallel output. That's why we are going to connect this to the ground or to the high. It doesn't matter. because if you are using serial input, it should be high, low, low, high. But if you connect it to one value, then you are not doing anything. This is first. Second, we have the serial input, the serial mode control that controls if you need to put a parallel input or a serial input. So where this comes from? This comes from this table that we discussed already before. If you put a low value on the S pin, then you are working on a shift register or a serial input. If you put high, then you are working on parallel load. So S should be connected to the high. S is on pin number 6. That's why we need to connect this to the high. So I'm going to connect pin number 6 to the high here. And also pin number 6 here to the high. So this is, this is 5. So let's connect this to pin number . Okay, and then here also pin number 6 to the VCC. Okay, so now we finished this pin here. Let's connect this to either high or low, it doesn't matter. And also I'm going to show you again the table. So when using parallel load, DS can be connected to the VCC or the ground. So that's what I'm going to do. We connected DS to the ground here and here. So now we finished the main connections, but we still have these two pins. The clock pin, pin number 8 and pin number 9. This is used when we are using parallel input, parallel output. So I'm going to connect a switch to this input, to this value. So this is pin number 8. Do you see pin number 8? So we connected this pin to a switch here. And also pin number 8 here is connected to another switch here. And if you look at this pin, it should be active low, which means it should work when we move from high to low. It means working with the low edge, not the high edge. And we already discussed this before, so let's not to waste more time on this. Why do we have these 4 green pins? I am doing this because we need to connect some LEDs, okay? So we can connect the LEDs here in this area instead of this area. Why? Because we are going to take another 4 lines from R2 to the ALU. So from R2 to the ALU. So we are talking about these 4 lines. So if you connect the LEDs here and take another 4 lines to the ALU from the same area here, this is gonna be confusing. So that's why I took 4 lines to this area. It is just wires, okay? The same applies to here. We take these wires to this area. Why these wires, not these ones? Because, because these are the inputs and these are the outputs. And the outputs of the R2 and R1 should be connected to the ALU and also should be connected to the LEDs. So if you look at this, the inputs are from pin 2 to 5 and the outputs are from pin 10 to 13. So now we need to make the connections from the bus to the registers. And by the way, for the ALU, if you remember, we have some connections. For example, we have the VCC pin number 5, okay? So VCC pin number 5, and we have pin number 12 to the ground. So this is pin number 12 to the ground, and we have the carry in pin number 13. We connected the carry in to the ground. So that is what we have here. Let's now start the connections, but let me tell you how the connections will be. So we have a pin here. So this is, let's say this is R1 and this is R2 and this is the ALU. So this is R1, ALU and R2. So we have inputs here. I want to ask you, where should these inputs come from? It should come from the bus, right? So I can say that this should come from bit 0, bit 1, bit 2, bit 3. What are these bits? These are representing the bus. The same applies to R1. So this should be, let me bring this. This should be bit 0, bit, do you see? Yeah. Bit 1, bit 2, bit 3. So the bus connection, which is this area, should be these bits here. So where these bits in our circuit, not in the bus circuit, where they should come from? From the switches here. So what we need to do is to connect the switches to the bus, which we already did, and then we need to take the values from the bus and connect them to the R2 and R1. So let's start with R2. We need bit 0 from the bus to pin 5 in the R2, not pin 2. This is very important. So bit 0 from the bus to pin 5, because this is the first bit on the right in R2. So let's start with this connection. Bit 0 to pin 5. So let's say bit 0, this is bit 0, here this one, to pin number 5. Let's say, where is pin number 5? 1, 2, 3, 4, 5. Yeah, that is good. Let's move to the second pin, from bit 1 to pin 4. So I am going to move from this pin to the second one, pin number 4 here in the circuit. And then we can apply the same for the other 2 pins. So from this pin to the next one. And finally, from this pin to this one. I want to ask you, do you see any difficulty here? I think everything is clear. Let's move to the same here, bit 0 from the bus to pin 5. So do we need to get a connection from here going up and then to here? Or we can take a connection from here to here directly, because this pin is already connected to this pin. This is easier, okay? So I'm going to take a pin from here to here. So where this pin should come from, let's take this wire here. So yeah, we should do something like that. I'm going to remove this pin because we need some space here. So let's take this pin. So let's take this one to this area, and then let's move this one to this one here. So the same pin, but just we need some space here. So from this pin to pin number 5 here, and then the next pin to the next one. So from this pin to the next one here, next pin, this one, to the next one here, and finally the last one, we can say it is from here to here. Yeah, I think, do we need to zoom in? I'm not sure. Let's zoom in a little bit. Okay. So now we finished the bus connection to both R2 and R1. Let me show you. So that means we finished this connection and this connection. Now we need to just put some LEDs on the output here, R2 and R1, in order to see what values do we have on these outputs here. So I am going to connect some LEDs on the output here, because we know already that this is our output. These are the pins that represent the output from 10 to 13. So from 10, this pin here, from 10 to 13, we should connect some LEDs. So let's connect the LEDs from this pin to the ground, and then let's take from this pin to the ground. Another one from the third one to the ground, and finally from this one. The same applies for this side, so I'm going to take another connection from here to the ground. If you see that this is boring, you can just increase the video speed so that you can go over this quickly. So yeah, but I'm trying to explain this to students who are not familiar with the hardware connections. So yeah, I hope that works fine. So now we finished the output LEDs for R2 and R1. Let's start we have two connections here, this one to the bus and this one, these two ones. Which one should we start with? Yeah, so for this one, we are not going to connect the ALU to the bus. Why? Because the ALU should store the value to the memory, right? So from the output here to the memory here. But we don't have a memory yet. What we need to do is to put some LEDs here in order to see the ALU output. Later on, we are going to connect this output to the memory instead of some LEDs. So let's put some LEDs on the output of the ALU. So this is, where is the ALU? Once again. So the outputs here are pins number, let's start with E2 or E1. I don't, do you see this image? Yeah, let's see here. So where is E1? E1 is on pin number 9. So let's start with pin number 9. I am going to do this. I'm going to take a wire from pin number 9. I think, yeah, we have this pin here. From pin number 9 to this area. And then I'm going to connect an LED to this area. But yeah, to this area here. And then an LED to this area. Okay, before connecting the LED, sorry, I'm going to connect these connections instead. Let's start with R2. So we take the output from R2 and connect them to the input of ALU. What we are going to do here is taking, let me see. So this is R2 and this is the ALU. We need to take these outputs from pin 10 to pin 13 and put them here. So let's take pin 10. This is, by the way, this is R2. So it should be connected to B here, not A. So pin number 10 should be connected to which pin here? I'm asking you. Try to think about this for a few seconds. Pin number 10 should be connected to B1 here, which is pin number 11. That's what we're going to do. So I'm going to take a pin from a wire from 10 to 11 here. So let's take this pin here. Which one? Let's take this one from here to pin number 11. So this is pin number 10. So this is 8, 9, 10. So this is pin number 10. to pin number 11. So this is pin number 11. 9, 10, 11. Okay, and then let's take pin number 11 here, this bit, to B2. Where is B2? Where is B2? B1, B2, pin number 7. So I'm going to do this. I'm going to take this one. Let me see if this is, yeah. So this one to pin number 7 here, this one. Then we need to move to pin number 12, Q1 should be connected to B3. B3 is pin number 4. So we need to take this one. I think we did a mistake here. Let's see the mistake here. Do you see the first one? It should be connected here because this line is empty. So I'm going to move them just by one pin here, like this. It is a small mistake, but it is very important to get things done correctly. So from here to pin number 4 here. Finally, from pin number 13 to pin number 16. Do you see this pin? Pin number 16. So I'm going to do this. From pin number 4 to pin number 16. Where is pin number 16? It is the last pin here. So that's what we have. So now we finished this connection. Let's go to this connection here. So let's see. We should go from pin number 10 here to pin number, we need A1, right? So to pin number 10 here. So from pin number 10 to pin number 10. We need this connection, I think, let's see, pin number 10, which one? It is this one. To pin number 10 here in the ALU, in the register. So this is 8, 9, 10, this one. Yeah. Then we should connect pin number 11 to pin number, where is 8U? Pin 8. So I'm going to connect this to pin 8. Sorry, do we have something wrong here? Oh yeah, so this is R1, so we should move from 11 to 8 here. So let's move from 11, sorry, where is 11? From pin number 8, yeah, so from pin number 11, sorry, to pin number 8 here. This is pin number 8. And then from pin number 12 in the register, so 12 in the register is this one, to A3. A3 is pin number 3 here. So, so from 12 to A3. We can do this here to pin number 3 here. Finally, we should connect pin number 13 to pin number 1. So pin number 13 to pin number 1. Now we finished this connection here. Let's now go to the output here. Do you see this pin? The outputs E1. E1 is pin number 9. So this is pin number 9 with the blue wire here. We need just to connect an LED here. So this is our ALD. This is our LED. And then let's look at E2. E2 is pin number 6 here. So I'm going to connect a LED to pin number 6. So this is pin number 876 to this part here. And then A3, where is A3? E4, no, we need E3. E3 is pin number 2, okay? So let's connect pin number 2 to E3. Pin number E4 is pin number 15. So I'm going to connect pin number 15 to another blue wire here to this area. And then another LED from here to the ground. Finally, we should connect the carry out, which is pin number 14. So pin number 14 is the carry out. I'm going to take a connection from pin number 14 here, this one. Let's take it from here to this area. And then let's connect this to the ground. I think we finished the connections now because we already connected this, and the output is connected to the LEDs. So let's start connecting the power supply. So this is our power supply. Let's zoom out a little bit. Okay. Let's now start. So we have 0 plus 0 is equal to 0. Let's put 1 on this R1 switch and put let's say 1 also on this switch. So as you see, 1 plus 1 is equal to 2. Let's put 2 here, so it is gonna be 2 plus 1, it is equal to 3. Let's put 3 here, so 3 plus 2 is equal to 5, 4 and 1. Let's put also 3 here, so 3 plus 3 is equal to 6, 4 plus 2. So let's put 7 here. 7 plus 3 is equal to 10. 10 is 8 plus 2. Let's put 15 here. So 15, it is 15 plus 3, it is 18. 18 is 16 plus 2. Okay? So let's put the same value here on register 1. So as you see, it is, I think 15 plus 15, it is 30. So this is 30. And yeah, this is what we have here. I think it is working now. So we already finished this area. We should move to the next, to the left area, or these components here. And that is what we are going to do in the next videos. I hope that is easy for you. And I know that I took too much time on this part because you need to know how to make these connections yourself, and that is this step-by-step explanation will make it easy for you and save your time. So that's all for today, and see you in the next video.